Welcome class to Chapter 10, Files and Exceptions. In this chapter, you'll learn to work with files so your programs can quickly analyze lots of data. You'll also learn how to handle errors so your programs don't crash when they encounter unexpected situations such as traceback errors. You'll learn about exceptions, which are special objects Python creates to manage errors that arise while a program is running. You'll also learn about the JSON module, which allows you to save user data so it isn't lost when the program stops running. So in this video, we are going to cover our first two objectives: reading from a file, writing to a file. Reading from a file. We can read from text files, and those text files can contain data such as weather, traffic, literary works, or user input. Reading from a file is useful in data analytics, or maybe just simply trying to present the data from a file to a web page. So in our first example, we're going to use the open method and the read method, and this example is on page 184. So our file name here is py_digits.txt. So we're going to create that text file so that when we open it, it actually exists. So I just want you to open up a text editor, and I want you to type the data that's in the middle of page 184. Hitting enter and 2 spaces in for our second line. And we'll save this file as py_digits. Okay, so now we have a file to read. It has 3 lines. So we use the with statement, with open, as, and then we give a name to our file. Okay, so a reference to our actual physical file. So then we use that reference and we use the read method, and the read method will dump the entire contents of that file, and in this case into a variable called contents, and then we're simply going to print out contents. So as expected, it's the same format as what we just typed in our py_digits.txt file. So to note, with the with statement, you do not need to have a close. So we have an open here and a read, but we don't have a close statement to close that resource. The with statement automatically does that for us. Also to note with the file paths, if I had this file stored in another folder, maybe such as text_files, I would just type that subfolder name. So when you're first practicing this, or continue to practice through Chapter 10, you're welcome to just have the name of the file. Just ensure that this file and this file, your py file, are in the same location. If they are in separate locations, just make sure that you code what location that file is in. Now if you're doing absolute path, you're going to start from the front with a /. Let's read line by line our contents of our file. So reading line by line, you use a for structure. So again, our file name is py_digits, and we're just simply going to use a for statement to run through each line in our file. So creating a variable that references the file name. Now we'll replace file name in here. And then we're going to use our for statement. So remember, our reference to our file is what follows the as keyword. And then we're not going to print out contents because that no longer exists anymore. We're going to print out line, which happens to be our one line at a time in our file. Now notice the results. We have a blank line in between the first and second line and between the second and third line. That is because when we typed this file, when we hit the enter key, it automatically inserted this, the /n, which is a new line feed. So to get that removed from our output, we can just simply put in rstrip, and that will strip that away, and now we have those blank lines removed. Making a list of lines from a file. So what if we wanted to take every line in our file and store it as one item in a list? Well, this example will step us through that. So in our with statement, we are going to create our list, which happens to be lines, and then outside of our with statement, we will then refer to that list. If you want to retain access to a file's content outside this with block, so anything that follows the with that's indented, then you must store those items in a list so that you can reference that list and on. So make sure that if you want to have access outside of the with statement, that you ensure that within the with statement that you use a list to store your lines of your file. So let's modify, and I'm actually going to go to a new example, and that is going to be, I believe, PyString. Nope. One second. I'm going to come back to this one first. So with open file name as file object, okay, we are going to create a list called lines, and in lines we're going to store one line at a time. So file object, a new method called read_lines. From there, we are going to run through our new list and print out our line using that rstrip once again. Oops. Okay, same results. But now we're outside of the with structure, okay, using this for statement, so we must make sure that we ensure that we're storing our file content within a list. One more before we jump into this one. And this one is on, we're actually not working with a file's contents is our next section. We're going to look at a new example called PyString. Okay, so same thing here. We have a reference or a variable that is referencing our pi_digits. So with open file name as file object, it's exactly what we saw before. Now we're going to create a brand new variable called PyString. So what our goal is getting these three lines down here in the bottom all in one line. Okay, so we're going to remove the spacing. There are the line feeds after, and we're also going to remove this space in front, these two space bars. So PyString, just an empty string for line and line. So we're running through our list, one line at a time. We strip off that new line at the end. We store that in PyString, and then we come through the second time with our number 89. We store that, and then lastly we come through 26. So that's our 3 steps through our 4, and then we print out PyString, and then we'll see the length of that PyString. So here are our 3 lines, but notice that the spaces here are still in front of the left, and it's simply because we used rstrip and not just strip. If we use strip, that's going to take it off to the left and the right. So now we have our pi number all together, and it is 32 characters in length. Our next example talks about large files, and it's a 1 million digit file. So I'm going to go ahead and open this file. Oops, I clicked on the wrong thing. going to open up pi million digits, and I will send you this file. So here is pi million digits.txt. Okay, we're going to use our next example just to print out just a certain amount of characters from that. So the same content that we have here, but instead of printing out all of it, which would be the million characters, we're going to just use an F string, and we are going to bring in pi string, but only 52 characters of it, and then 3 periods after, or an ellipse. Now I need to change this up here to be million digits to have the correct file. Okay, and so now I have my 52, and then I have the length right here telling me that I have a million characters or more. One more example that we're going to work with, and it's called Pi Birthday. Pi Birthday uses the same content that we had before, these first lines here, but instead of the output that we had here, we're going to do an input so that we can input a birthday and then see if that birthday exists in our million digits in our file. So in order to run this, we got to remember that if we're using Sublime, that we have to run from our terminal. So my chapter 10, and then I'm going to run, and it should be, what did I name the file? Pi Birthday. So my birthday, your birthday appears in the first million digits of pi. Now I had a student this morning that I believe was this birth date. Maybe not. Maybe it was 28. So some birthdays will be there and some not. I had about 2 or 3 students that weren't in the file. Okay, so remember to navigate to your folder and then execute the file from there. Kind of neat, kind of a neat little program. So that leads us to our first lab, and that's 10-1, Learning Python. Open a blank file in your text editor and write a few lines summarizing what you've learned about Python so far. Start each line with the phrase, "In Python you can." Save the file as learningpython.txt in the same directory as your exercises from this chapter. Write a program that reads the file and prints what you wrote 3 times. So all 3 examples that we went over today. Print the contents once by reading in the entire file. That was the very first example that we covered, and that was on page 184. Print the contents once by looping over the file object. Okay, so looping over the file object is our example on page 187. And then working with them outside the with block. Okay, so using the list, and that would be your example on page 188. Next, we'll cover writing to a file. So writing to a file. One of the simplest ways to save data is to simply write it to a file. We do it every day. Output is still available after you close the terminal or run your program in an editor. Okay, so we write it to a file. We then have access to it later on, even though we're not in the terminal in our command prompt or in our editor. You can then examine the output after a program finishes running, or you could share the output, or you could read or work with the file later. So we have 3 little arguments that we'll work with, and W happens to be one of them, but we'll also work with A for append, and we're going to work with R for read. So let's check out this example. write-message.py. So with write-message.py, we are open the file for writing. You want to be very careful with the writing. Okay, so the file, if it doesn't exist, it's going to create programming.txt in the same directory that this file write_message is stored. If the file does exist, it's going to overwrite all the contents of that file. Now, if I didn't want it to write over the contents of an existing file, I would then use A to append that data to that file. Okay, so let's go ahead and write this and we'll get a file. Okay, we get no output, but now I'm going to go to my directory where I'm running write_message from. And now I have a new file called programming.txt, was just brand new created, and there it is. I love programming. Let's practice other examples with this using different modes. Or actually, let's first write another line to it. And let's see what happens here. So you could write as many that you need. File object dot write method. And they want us to write, I love creating new games. Run it again. Open up programming.txt, and this is my output. Now if I wanted everything to be in a new line, you guessed it, /n at the end. Make sure it's inside the quotes. And now I have them on two separate lines. Okay. Let's say that I wanted to make sure that these two lines still existed, but I wanted to add in a brand new line. Okay. So I'm going to do that with the example that's on page 193. Okay, so 193 has got the text messages. I also love finding meaning in large data sets. I love creating apps that can run in a web or one in a browser. Now, I'm going to take a backup of this programming.txt. Okay, now I have a programming.copy. Okay, and I'm going to go ahead and run this file just as it is with W. And I'm going to open up programming.txt. Just to demonstrate to you that if you use W, it's going to overwrite the current contents of that file. So you want to make sure that when you want to just add to the file, that you go ahead and use append. Okay, so now I'm going to delete programming.txt. I'm going to back it up to my previous copy. Open this file to show you that it's the previous two statements. Let me go ahead and close. I got a few of these open. And now I'm going to change this to A and run it. Now I'll open up programming.txt and notice my two lines are now added to the file and not overwriting the existing content. So these modes are really important. W, again, is going to erase any existing content. Append or A is going to add to the file. And of course, read will just allow us to read the file. So our lab for this section is page 193, and it is programming poll. Write a while loop that asks people why they like programming. Each time someone enters a reason, add their reason to a file that stores all the responses. So let's look at this one. I'm actually going to do it this way. Copy address. Open my terminal again. Actually, I think I can just do it this way. 10. Nope, this is a different folder. Okay, there we go. And it is 10-5.py. So why do you like programming? Because it's fun. Would you like to let someone else respond? Yeah. Why do you like programming? Because when code is broken, it's fun to find out why. I'll do one more. Why do you like programming? Because logic is fun. No. Okay, now I'm going to go ahead and look at my solutions folder, and there is my programming_poll file.txt. That's the name of the file that I created, and those are my 3 responses. So that's how 10-5 should behave. If you have any questions on any of the examples that were gone over in Chapter 10 for the first 2 objectives, please let me know. Thank you.